Hi everyone. Today is topic 2 of chapter 4, describing distributions of numerical variables. So today we're going to learn about how to look at a graph and then talk about the key characteristics of that graph. What does this graph tell us? Okay, and what specifically are those key characteristics that we should be discussing? So, when describing distributions of numerical variables, it's important to consider 4 key characteristics, and I like to use the word SOCS to help me remember what those 4 key characteristics are. SOCS. Okay? The first one is shape, and we will spend the rest of today's notes talking about these specific characteristics in full detail. So don't worry about if you don't understand what they mean right at the beginning. So shape, outliers, center, and spread. Okay? So like I said, when describing distributions, we want to talk about 4 key characteristics represented by SOCS. Okay? So, first one, shape. What does that mean? Well, there's 5 main ways we can kind of categorize a graph shape. The first one is symmetric. So for each one of these descriptions, you guys, I'm going to verbally describe it as well as describe it with a quick sketch. So a symmetric graph is when the left side of the graph is a mirror image of the right side of the graph. A lot of times we use the term approximately symmetric because it's never going to be a perfect mirror image of one side versus the other. So a lot of times you'll see me write approximately symmetric. Okay? So what does that look like? I'll draw these in terms of histograms since that's what we looked at yesterday. Okay, so it kind of looks something like that. Mound shaped a lot of the times, but left side of the graph is a mirror image of the right side of the graph. Skewed right. Skewed right is when the right side of the graph is more spread out than the left side of the graph. So the right side of the graph, more spread out. Okay, so skewed right graph could potentially look something like this. Okay, a lot of the times I'll tell you, or you'll see me drawing curves over these graphs to help us to determine which shape it has, but do you see how it kind of has like a longer, what I call right tail? Skewed left is the opposite. It's when the left side of the graph is more spread out than the right side of the graph. So skewed left may look something like this. Again, if you kind of draw a curve over it, it has more of a left tail to it. Bimodal is when the graph displays two distinct peaks. Okay, so they're distinct, so they're not next to each other. So, bimodal graph may look something like this. Okay, the two peaks are not next to each other. The last category we can put the shape of a graph into is uniform, and that's when all the height of all the bars are approximately the same. Just like for symmetric, a lot of the times you may hear me say approximately uniform, because they're never going to be perfectly all the same height. Okay, so a lot of times we might use approximately in front of that too. You don't have to, but it's never going to be perfect, so approximately like gives it a better classification. So let me draw you that sketch. Okay, the heights of all the bars are just about the same. So now would be a good time to pause the video if you want to try these four on your own, or you can work along with me. First one, like I said, if you need to, draw a curve over it. What do I see? That would be approximately symmetric. Or if you just wrote symmetric, that is fine too. Next one, I'm going to draw my curve. For this one, that is going to be skewed left because of the left tail. Next one, the heights of all the bars are about the same, so that would be approximately uniform or uniform. Then letter D has those two distinct peaks, and we call that bimodal. So that should cover shape. Now let's move on to outliers. Recall, an outlier is a value that does not fall in a pattern with the rest of the data. Now keep in mind, an outlier can be in the lower direction, on the lower end, or the upper end. And a data set does not have to have outliers, or a data set can have multiple outliers. So it's important to identify these extreme values for several reasons. One is that they could indicate that a data entry needs correction. For example, once, as always, teachers are human, so they make mistake. I entered in someone's test score for the Chapter 3 test, which was out of 50 points. I entered it as 4 out of 50 rather than 44. Okay? 4, if I would have examined my data set and noticed that there was an outlier 4, I probably would have noticed that that data entry needed correction, and it was actually a 44. Okay? Next one is that they could indicate a special phenomenon that deserves to be recognized. Okay, for example, when Kobe Bryant had a game where he scored, I believe it was 81 points. That was definitely an outlier in his career, an outlier for players that season, and it definitely deserves special recognition. And the third reason we should identify these extreme values is they can have, to recognize the heavy influence they can have on summary statistics, such as the mean and range. So they can heavily influence summary statistics. Such as the mean and range. Okay, and if you forgot what mean and range mean, I'll tell you right here with these next two. So that's O, the O part of SOX, another special key characteristic to acknowledge for describing distributions. The C stands for center. And two common statistics we can use to talk about center is the mean, which another word for mean is the average. So add up all your data values and divide by the total number that you have. Or the median, which is your middle number. So if I were to put the data set in order from in numerical order, it would be the number in the middle. If there's an even set of data points, they take the average of the middle two numbers. Now in this class, I never take your calculator away from you. So I'll show you in just a second how your calculator calculates and how you can find the average or the mean and the median on your calculator. The fourth and final key characteristic of describing distributions is talking about the distribution spread. So one statistic that's common that we can use to describe spread is the range. The range is the max minus the min. Keep in mind the range is a single number. So if my highest test score in the Chapter 3 test was a 48 out of 50 and my lowest test score was a 28, I wouldn't want to say my range is from 28 to 48. I'd want to say my range is 20. I'd want to subtract the two values. Next one, the next statistic that we commonly use to describe spread is what's called the interquartile range, or abbreviated IQR. And that is the difference between quartile 1 and quartile 3. So that would be quartile 1 minus quartile 3. Quartile 3 minus quartile 1. Or in other words, Q3, we abbreviate it with Q3 minus Q1. And again, your calculator can find your quartiles for you. Just highlight a few of these formulas for you. And just like the range, the IQR is also a single number. So give me the difference between those numbers. Okay, so I think it would be good to do this next one together. So let me show you how we're going to type this in our calculator, and let me show you how we would describe the distribution for this one. So let's go ahead and type this data into our calculator. So in order to type this data into our calculator, you need to go to Stat and then Edit. If you have any, let's say I had some values in my list, in order to clear out my list, I arrow to the top so the list number is highlighted, hit clear, which is right below the down arrow, hit clear and arrow down, and that clears out your entire list. Now, the delete button is also close by. Make sure you don't hit delete because it will actually take away the entire list as itself. It won't just clear it, it will actually remove the list from your set of tables there. So make sure you arrow to the top so the list number is highlighted, hit clear, arrow down. Now, go ahead and carefully type in each of your data values here. Between each data point, just hit enter and it will type it in. You should have 14 pieces of data. So when you're done, it's almost like it's ready for data entry number 15. Now, so we're going to talk, it says describe the distribution. Remember, describing the distribution means talk about the 4 key characteristics represented by SOCs. Okay? So I know it says you can draw a histogram to help. You know what? Just take a look at the histogram. You don't need to know how to do it on the calculator. I actually think it's easier to do it by hand. But take a look at the histogram just to save some time. I'm going just to graph it for you on the calculator. And in SOCs, we're going to start with S, stands for shape. So the shape of this one is kind of tricky, not going to lie. Sorry, it's the first one I'm really giving to you. It's one of the trickier ones. So you really need to look at kind of imagining drawing a curve over it and what shape best describes it. Sometimes there's not one that best describes it. Sometimes there could be 2 here. In the past, I think my students and I agreed that it's a little bit, your data is a little bit more stretched out this way. So we are going to call it skewed left. If you didn't get that, please don't panic. This is, like I said, one of the trickier ones. So our shape is skewed left. Now, the next part of SOCs is O for outliers. Does there seem to be any unusual data values here? Well, opinions could be different here. Okay, we're actually going to have a formula later on in this chapter to help give us, to distinguish outliers. But for right now, we're just kind of looking. So in a histogram, you're really just looking for any gaps. And I do see a gap in the data set here. So this number right here could be a potential outlier on the upper end. Your data was in numerical order for you, so that number appears to be 901. So let's take the shape and the outliers and kind of weave that together for one sentence. So describe the distribution. The distribution is, and even if you wanted to, you could use the word slightly, because it's just, but you do not have to, skewed left. That's just the math teacher in me wanting to use that. With a potential outlier at 901. Now, we don't know for sure if that's an outlier. Like I said, I'm going to give you a formula to use later in this chapter, but there is a gap there in that histogram, so I'm thinking 901 is potentially an outlier. Now, we have center and spread to discuss next. Okay, so you entered your data into a list. So now you can go to Stat, arrow over to Calc, and hit number 1 for one variable statistics. Some of you might see something that says like list, frequency list. Just make sure it's for list, it says list 1, and then enter on through. And you get a bunch of statistics here. Not sure if some of you guys remember, but from Algebra 2, X bar, this very top number right here, is your mean. Okay? And then if you scroll down, N is your sample size. We had 14 pieces of data here. I get my minimum, I get Q1, which is quartile 1, I get MED, which is my median, Q3, and my max. And remember, max and min can help me get my range, Q3 and Q1 can help me get my IQR, both which are used for spread. So, if you need to, just to write in the corner, to get that to come up, we did Stat, arrow over to Calc, and it was number 1, which was one variable statistics. Okay, for the calculator work there. So, now for center and spread, when you describe your distribution, talk about your center and spread, you need to tell me what statistic you're using, okay? Are you using mean or median for center? Are you using range or IQR for spread? So I'm just going to go back to my calculator and arrow up. I'm just going to use the mean, which was 774.6. So the center of the distribution can be described using the mean of 774.6 and the spread with the, let's use the IQR. Remember, IQR is Q3 minus Q1. So if I scroll down, my Q3 was 821, my Q1 was 714, so my IQR is 107. Keep in mind, you could have also described your center with the median, which was actually 785.5, and you could have also described your spread with the range, which was 255. Please make sure anytime you describe the distribution that it's in complete sentences. You should be able to weave it in, it should only take you 2 sentences. You know, make sure you use proper grammar, punctuation, okay? So please don't forget stuff like that in this class. But it is important, and there's friendly reminders on your worksheet tonight to use complete sentences when describing the distribution. Okay? Please keep your notes out to you when you're working on your homework. They're going to be a big help, and good luck.